Hello viewers, now we are going to see about design of bearings. First of all, what is mean by bearing? Bearing is a stationary machine element which support another moving machine element, right? It can be known as journal, right? It permits a relative motion between the contact surface of the members while carrying the load. So there is a concept which is behind the bearings, right? So it will increase, mainly it will increase the efficiency of the power. So when we'll apply some lubrication, some fluid between the journal and the bearing, so that will increase the efficiency of the power. That is a concept which is behind the bearing. Second one, what are the classification which is in the bearing? First one, which is based on the type of load acting on the support, that is radial bearing and thrust bearing. So radial bearing is nothing but the load which is acting perpendicular to the direction of motion. So see here shaft axis in horizontal, but load is acting in vertical. That means the load which is acting perpendicular to the direction of motion of the moving part, right? That is the concept of radial bearing. But in thrust bearing, the load which is acting in the axis, or we can say the load which is acting parallel to the shaft or parallel to the moving part, that is mean by thrust bearing. Next one, classification, which is based on the nature of contact. So nature of contact is two types. One is sliding contact and rolling contact bearing. Sliding contact is nothing but sliding contact is nothing but sliding take place along the surface of contact between the moving element and the fixed element, right? The sliding contact is also known as plain bearing. There is no contact between the, we can say there is no contact between the, no material or element between the moving element and the fixed element. So that is meant by sliding contact bearing, right? And in rolling contact bearing, right? In rolling contact bearing, a steel ball or roller are interposed between the moving and the fixed element. Some of the rolling element, right? Some of the balls which will be placed in between the moving and the fixed element. So that is mean by rolling contact bearing, right? And what are the types of journal bearing? There are three types of journal bearing here. One is full journal bearing, and second one is partial journal bearing, and another one is fitted journal bearing. So there are various figures are given. Full journal bearing is nothing but it will cover 360-degree, right? Partial is nothing but it will not cover 360-degree, and fitted is nothing but there is no gap between, there is no clearance between the journal and bearing. We'll see clearly. Full journal bearing is nothing but the angle of contact of journal with the oil is 360-degree, right? It is capable of supporting the radial force in any direction. That is meant by full journal bearing. But in case of partial journal bearing, the journal has less than 360-degree. It will not cover full 360-degree. It will cover less than 360-degree of contact with oil, and it will support only unidirectional load, right? It will support only unidirectional load. That is mean by partial journal bearing. And in case of fitted journal bearing, the diameter of the journal and the bearing are equal. That means there is no clearance between the journal and bearing. See here in the figure, there is no clearance between the journal and the bearing. And one more thing is diameter of journal and bearing are same. That is mean by fitted journal bearing. And so this is the design procedure of journal bearing. First step was we have to calculate the diameter of the journal, right? Diameter of the journal we have to calculate with the help of given power, right? Power will be given in the problem, right? So with the help of power you have to calculate the diameter. For that formula is mt is nothing but torque, right? Twisting moment. Mt equal to pi by 16 into tau into d cube. There you have to calculate the diameter of the journal. Second step is to select the suitable L by D ratio. L by D ratio is nothing but length to diameter ratio, right? Length to diameter ratio to calculate in the second step. And third step, you have to calculate the bearing pressure with the help of, right? With the help of L by D ratio, right, with the help of L by D ratio. That means P equal to pressure P equal to W divided by L into D. That is the third step. Fourth step is nothing but you have to select the clearance. So clearance, where we have to give the clearance between the journal and the beam. I mean journal and the bearing, right? Journal and the bearing. So that is the concept here. C by D ratio. And fifth step is to select the suitable oil to increase the efficiency of the moving part, right? When increase the efficiency of the moving part only, we are giving the bearing and all. So that is the main concept. You have to select the suitable oil. And sixth step is calculate the bearing characteristics number, that is Zn divided by P. Whether it may be a Sommerfeld or it will be a McKinsey equation, what it may be. So with the help of that equation, you have to calculate the bearing characteristics number Zn divided by P. You have to calculate. And seventh step is determine the Sommerfeld number, right? Determine the Sommerfeld number. And eighth step is calculate the coefficient of friction, right? Coefficient of friction with the help of McKinsey equation, right? With the help of McKinsey equation, you have to calculate the mu value, right? Coefficient of friction is nothing but you have to calculate the mu value. And ninth step, right? And ninth step is nothing but you have to calculate, you have to go for heat generation. There two things will happen in the bearing. One is heat will be generated in the bearing and some amount of heat will be dissipated from the bearing. That you have to calculate. Understand what I am telling? The thing in heat calculation, two things will be considered here. One is heat generation in the bearing and amount of heat dissipated from the bearing. So heat generation is Hg and heat dissipated is Hg. That you have to calculate here. And one more thing we have to consider here is heat dissipation, right? Heat dissipation will be more than the heat generation. That means there is no artificial cooling is required. If the heat generation is more than the heat dissipation, for that artificial cooling is required to cool the bearing, right? That is the concept which is behind the bearing. These are the major steps which will be used for designing the bearing, right? So this is the procedure for designing the journal bearing, right?